So we got a couple problems here dealing with exponential growth, and let's talk about how we can set those up and solve them. So first off, what is the effective yield on an investment paying 6.039% compounded continuously? The effective yield is what the rate would be if it were an annual rate. Now, to compute the effective yield, now we have two forms of an exponential function. We have a b to the t and ae to the kt. To get the effective yield, all we need to do is find that base of our exponential, subtract 1 and turn it into a percent, because that'll be our growth factor. Turn it into an annual growth rate, subtract 1, turn it into a percent. This form is necessary especially for this problem because k is what we use when we have a continuous rate, which we do here. So the nice thing is the a's are the same and the t's are the same, so what we have is that b equals e to the k. So this e to the k is our base. So e to the point, don't forget to turn it into a decimal, 0.6039, that is our growth factor. Okay? That's huge because to turn a growth factor into a rate, all we have to do is subtract 1 and multiply by 100%, and we will have our answer. And we can put it in exactly how we have it written there. So, second e to the x to the point, let's move that there, 0.6039, and the parentheses minus 1, enter, times 100 to turn it into a percent, and we got 6.225%. So, always find your growth factor, subtract 1, and turn it into a percent, and that'll give you your effective yield or your APR. Now, what is the doubling time if we have an annual growth rate of 5%? So now it already is an annual growth rate. So the growth factor is 1.05. So our basic formula is going to be y equals a times 1.05 to the t. And what we want to know is when will this double? So we can use anything we want for our initial amount. It won't matter. So if I use a, I basically want to know when it's going to be 2a times equals a times 1.05 to the t. Alright, because I'm looking for when this doubles. First step will be to divide both sides by a, and I get 1.05 to the t equals 2. That's not a coincidence. It's because we're looking for doubling time. So here's the equation we have to solve. Now we're going to use logs because we want to solve for a variable and an exponent. Since we don't have a base of e or a base of 10, it really doesn't matter what log we use. I'm going to solve this one taking the log of both sides. The other way is you could rewrite it as a log with a base 1.05. Use the change of base formula in your calculator to solve. I'm going to take ln of both sides. The reason I do that is because I can apply a property of logs that allows me to pull the t out front. So I have ln of 2 equals t times ln of 1.05. And last step in solving for t is divide both sides by ln of 1.05. Now clearly, none of our answers are put in this form, so we'll bring back our calculator. ln of 2 divided by ln of 1.05, and we get the answer about 14.2 years is the amount of time it will take for it to double.